looking at probability rules, we discussed the basic rule of probability. We talked about complement rules, and then we talked about problems involving, and then we talked about problems involving or, and then we talked about how to find the probability in either A nor B. Now we want to talk about independent versus dependent events. Now first let's look at what are independent and dependent events. Now independent is, now if occurrence of event A does not change probability of event B, so occurrence of one event does not change probability of another event, then A and B are independent events. So if occurrence of one event does not change probability of another event, then two events are independent events. If occurrence of event A changes probability of event B, then A and B are dependent events. So if occurrence of one event changes probability of another event, then they are dependent events. Right? If two events are not independent, then we say they're dependent events. So if the occurrence of one event does not change probability of another event, then they both are independent events. And if they're not independent, then we say they're dependent events. Now let's look at how do we mathematically check for dependent or independent events. Now, two events, two events E and F are independent if and only if the following equivalent conditions hold. Equivalent conditions hold. So all of these are equivalent conditions. We'll look at what this means in a bit. Number one, probability E given F is equal to probability E. So the probability of E same or the same regardless of whether probability of E same regardless of whether F given or not. In this case, probability, so like we said, now, the occurrence of one event, in this case, F does not affect the probability of occurrence of event E, so E and F would be independent, right? Similarly, probability of F given E is equal to probability of F, right? So probability of F same regardless of whether E given or not. So the occurrence of an event, in this case event E, does not affect the probability of occurrence of another event F, right? The conditional probabilities are equal to unconditional probabilities. And third, the probability of E intersection F, we can just write as EF, right? So this is probability of E intersection F is just equal to the product of the individual probabilities. Right, so two events, so if two events are independent, then these equivalent conditions hold. This condition is that, so this is that conditional probabilities are equal to unconditional probabilities. Conditional equal to unconditional probabilities. And this says that the joint probability is equal to product of individual probabilities. The probability of the intersection is equal to the probability of the individual probabilities. Joint probability is equal to product of individual probabilities. Now, what do we mean by equivalent over here? Now, the implication of equivalent over here is since all conditions imply one another, so if we prove any one of these conditions, we have shown A and B are independent events. If we show any one of these is not true, again, any one, we have shown A and B are dependent. So you don't have to prove all three to show the independent. Similarly, you don't have to disprove all three to show they're dependent. You just need to show any one is true, and that will prove that they're independent. You just need to show if you show any one of these is false, then you'll show they're dependent. So two events C and F are independent if and only the following equivalent conditions hold. Because these are equivalent conditions, they imply one another. So just proving one of these is enough to show they're independent, and disproving any one of these is enough to show they're dependent. So you just need to prove or disprove any one to come to a conclusion.